Hi, everyone. I just wanted to say that if you have any questions or anything like that, or comments, like feel free to interrupt me as I'm talking. But other than that, I think we'll just go right into it. So on my screen, I have in the corner like the link if you want to follow along on the slides on your own. But other than that, what I'm here to talk about is Agile deployment of CakePHP web applications in a hybrid Kubernetes cluster. Like kind of an introduction is the state of space science has changed quite a bit in many years. So like I'm sure you've heard the saying that the Apollo computer processors are like less than people's smartwatches nowadays. And that's like beyond true. Like the original Apollo computers were 0.05 megahertz. And you can compare that to literally any phone today. And it's like 100,000 times better of a processor. And so what that means is the ways from before aren't really applicable today. And so we need faster, better, and more robust ways to process all this data that's coming in. So in the past, we used to bring this data in either CSVs or Excel files and import them into the software. But now the data volumes have gotten so large, it's actually better to move the software to the data. And so that brings containerization, which has been covered before. So there's two CakeFest talks in the past that I kind of relied on. And so I've linked them here. They're a little bit different than what I'm going to cover, but I recommend watching these later if this is something you're planning to implement in your Cake applications. So a little agenda. So I plan to talk about me, then what we do at Southwest Research Institute Space Science, what we needed and why containerization and this sort of methods of deployment were needed, and how we got to where we're at, what tools we used and found useful and not useful, and then what we plan to do in the future. And then lastly, I'll finish up with some question and answer. So as for myself, I'm Umer Salman. Online, I'm Umer936, which makes it pretty easy. But I work at Southwest Research Institute in San Antonio, Texas, and I've been there 2.5 years. So my degree is from University of Texas at Austin, and I actually have an electrical and computer engineering degree. So I've worked with hardware as well as software. I've been using PHP since the Nintendo DSi. So actually, I had the Nintendo DSi, but I didn't have any games. So the web browser could run a lot of stuff, and so people came up with like the Nintendo DSi community, which is basically making PHP social media sites on it. So all the debate about like IDEs and stuff, Vim, PHP Storm, at least you're not using a touchscreen with a stylus. Then I've also done work in robotics and cybersecurity, and I like a bunch of stuff, including cars and tropical weather and all kinds of things. So Southwest Research Institute. We do a lot of cake development. I've been there only recently, so Cake 4 was already out. But my group has been using CakePHP since the 1-point-something days. And we have over 45 CakePHP projects, specifically for supporting space science operations. And we're constantly using all kinds of things in the CakePHP ecosystem, including the different user account plugins like auth and ACL, our own one, CakeDC users, TinyAuth. So we kind of touch on everything, with so many applications, we find a way to use different ones. And then we also use DineroMarQ and CakePHPQ, so I'll cover those later. We also override some of the things in Cake, so I'm expecting to find out if those are bad. And then we also modularize these things because we don't want to duplicate things across so many applications. We use a lot of Bootstrap, and one thing we do in common in a lot of these applications is interface with a lot of like space science code bases that are written by scientists. And so we kind of treat those as like a black box sometimes and provide an interface to work with IDL or Python or C++. Some examples of applications we build. So this one in particular, GeoViz, has a C++ and IDL program behind it. And essentially we provide a front end for it and like user accounts. And so there's a giant drop-down list of different space missions, including like Voyager 1, Voyager 2, Lunar Reconnaissance Orbiter, and the scientists can configure the parameters to interface with that application rather than having a giant command line and stuff like that. So this is one place where actually the containerization and queue stuff is actually very important because the program that runs these is actually like large and complicated and runs a lot of math. And so we have, you can see on the sidebar, we have a queue, and the scientists will have 300 plus things in this queue with like thousands of frames each. And so being able to provide that in a way that doesn't take a whole week to chug through is what we are looking for and doing. And then this is kind of an example of what it spits out. So you can see like what comes out from doing those parameters. So you can choose to like have it use different star maps, or you can set the different kernels for like the flight plans. And so they use these for flybys to determine whether specific instruments should be like on or off at certain times in the flight plan. And so we use the queue a lot in that. And so we've taken GeneroMark queue and extended it to like include our parameters, and it'll filter out all the ones that are like the default parameters. So that way when something screws up, we can see exactly what's different from what the user selected and what we know is like good and proper. And because there's a lot of moving parts in each step, and so it tells us whether the error is like in the IDL code or on the system, or if it's there's just no data for that time range. And then the site is actually live and open to the public as well. And we have user accounts. And so, yeah, so this is what it looks like. Another application, we do kind of the same thing in a lot of places. So in this case, we also take space science data, and there's 4 spacecraft that have this same type of sensor in it. And so for HPCA, the Hot Plasma Composition Analyzer, you can see the running site. The scientists are able to look at the plots and like zoom in and all that good stuff. I don't know the science data. That's their job. We just make it nice and easy for them to use. And then we also do some conference softwares for like all completely in CakePHP for managing conferences related to discussing like the findings from these missions, so specifically for Juno. And we have these very modularized, and so we're able to spin these out really quickly with just like forms and whether they submit abstracts and so on. But we use that same modularization ideas in the more complicated science ones. So we have our Science Operations Center, and this is actually where we've done the most work in the containerization, because we have all these different parts on the left, and some of these can be processor intensive or need a lot of storage, which we don't want to do on the bare metal like server. And so we do, again, the same application for multiple different spacecraft and different missions. But you can see they all generally look the same. And I'll talk about how we do that and manage all those different code bases together in a little bit. I'm going to go into like the terms that I plan on using. Oh, one last thing is I wanted to point out, see these plots towards the middle here on Visio. Those kind of look like the same plots that are on HPCA. And so we don't want to duplicate that processing stuff. And so it's very important that we're able to move these out in a way that we can use it on these completely different applications. So some terms I'm going to be using are Docker and containerization. And Podman is another one that's like Docker, but I'm just going to use containerization probably to mean any of them. And there have been other, there's a lot of resources on like what that means. But in short, it's just like a way to stick your application and its dependencies in, you can basically think of as like a shipping container. And in the shipping container analogy, the transportation cost becomes negligible. And so that was what changed shipping throughout the world. And so containerization is kind of the same thing in software, where now you can take that container, move it to a high-performance computing cluster, you can move it to Amazon Web Services, and just expect that everything's packaged together, and you don't have, you know, wires sticking out the sides. I actually used to think that containerization was kind of silly because I thought it was a bad idea to just ship all the dependencies with your software, because you should just make your software better and like not have those problems where it only works on your machine. But sometimes there's just so much that you have to, like, it really solves a lot of problems. Then Galley I'll be using to refer to Alex Mayer's CakePHP plugin. I mentioned it earlier, but we've been using that quite a bit, and it's he has a CakeFest talk from last year about it. And then Kubernetes. Kubernetes, actually the term comes from helmsman, which means to pilot, and specifically like for boats. And so Docker has all kinds of like boat-related terminology, and so it's actually becomes easier to think about it in that way. So Kubernetes is a way to manage those Docker containers, to pilot them around on what systems they're at. AWS is Amazon Web Services. It's Amazon has a cloud hosting platform for you to stick your software on. And then S3 is Amazon's way that they've determined how to do storage in cloud environments. And so, but it's a standard. So you can actually have an S3 bucket or container for storing your data and not have it be tied to AWS. And then microservices is like the idea of having each part of your applications be their own containers. And so they just have one responsibility rather than you have something that has multiple responsibilities and you take all those services and make them as small as possible. This slide is a little, there's a lot of stuff on it, but I'm just gonna go through the key points. And but basically we needed to decide what was best to do, because we knew running bare metal, which is what we've been doing for quite some time, isn't the best. Now it's tried and tested, and there's a ton of like documentation and resources on how to do it, and you know, you don't have to deal too much with like HTTPS certs and stuff, but it causes problems with updates. So PHP 8 is out, and moving the web server that has PHP on it to PHP 8 is going to break a lot of things. And so if each application is dependent on that same one on the bare metal, then you're stuck until you figure out how to go, you know, with 40, 5+ applications and be able to bump it up. And then same with security, is you can only manage so many things. And so if one site gets hacked, then now they have access to your entire server because it's all running on bare metal. And then you have potential for conflicts in between them. Maybe you want a different MySQL version, but you don't get that option because everything's installed just in the on the OS. And then you don't have portability. Everything has to run on the web server. And so if the power goes out, something like that, then you got to wait. Cloud is the next option. If you talk to anyone over the last few years, they would have said that cloud is the way to go, like 100%. And like it very much was kind of hype trained. And it's really nice, because you can have the whole infrastructure not be your job. It's Amazon's problem. The data center catches fire, they'll bump it to a different, Amazon or Google data center, and you don't even notice. It adds 20 milliseconds of delay or something like that. They handle the backups, the speed, because it's distributed, and they really push you to do microservices. The problems begin where it becomes expensive. So even Amazon itself realized this because for Amazon Prime Video, just last year, or I think it was early this year, they dumped AWS for its video QA team, and it cut their hosting costs by 90% because they realized that trying to do everything within the ecosystem isn't sustainable. It's good to help you grow, but at a certain point, then you got to start cutting costs somewhere. And so it's also super complicated. So AWS itself has 240 different containers options for things that they supply on their own, and you can deploy your own containers as well. So it becomes, this giant landscape that is impossible for someone to know without becoming an expert in just doing that. But we're web devs, so we shouldn't be doing that. And then microservices, I put that also in the con side because if everything is only doing the one thing, then there becomes just too many moving parts that, again, you get distracted from the point of actually web developing. Docker, WAMP, and Laragon, they were actually mentioned in an earlier CakeFest talk today. I like that the fact that they create the separate environments per app, which reduces the cons from bare metal, where you can keep things separate and not have the conflicting versions and things, but it doesn't deploy to the web server well. And so I'm going to kind of gloss over that one because we've covered it already. But then Docker Compose, this one, actually Galley, again, we talked, has been covered a bit before, is pretty helpful. And Devilbox operates in a similar fashion, but they're pretty straightforward and allow the separation, and they also allow you to deploy it to your web servers for production. So that's actually really helpful. But they're not distributable, and they don't really scale. So if you want to have multiple containers of a certain type, then you need Kubernetes. And so Kubernetes is nice because you can now manage all those containers. And you can do it either pure Kubernetes, where you have it all in one location, either an on-premises server or an AWS, or you can do a hybrid where you have some parts in some place and some parts in another place. But again, that gets complicated. And so Rancher is a tool to manage that, and it basically describes it as treating your containers like cattle. And so the containers are disposable and they can be thrown to whatever pasture. But you kind of have to go all in. You put all of your things in containers and you're good to go, but otherwise you have a little bit of friction, and there's only so many things you can containerize at once. So we went with more of a hybrid where we containerize some things and deploy in some different places. And so this allows a lot of progressive enhancement. So the thing I mentioned earlier, if the container is available for it to run on a different computer, that's awesome. It'll go through, it'll run. But in case that system is down, then it'll fall back to the bare metal host. And what we don't have yet, but we want to do, is where it'll also fall back to AWS if even that one is down. And we'll just pay the AWS fee because it's worth it to have things online versus just be stuck. And then we're not locked in any way. But again, it's more parts to keep track of, and it's not always optimized like you can have your containers being, because you have different overheads for different things. So now that we've had kind of decided that we were going to containerize certain things, but not everything, we thought of what we wanted to containerize. So our plotting library is called SDDAS, and it's like data acquisition, and we needed that in a container. And we went ahead and just used Ubuntu because it's got everything and ready to go. It needs a GUI, and so that actually caused some challenges in the Docker Compose, but we were able to figure out how to do it. Then we needed the web pod, which is our CakePHP applications. And we just use Nginx, and we based it very heavily off of the Galley method of creating these containers. And we ended up not using NPM for anything and just doing everything server side with HTMX for like not having to do JavaScript rendering or client-side rendering. Then we needed a messaging container to communicate between all these different parts. So we went ahead with RabbitMQ, and then databases, MySQL and Postgres. There's other more cloud-native database technologies like CockroachDB, which we've looked into, but we just haven't gotten to that point. And so we've just been keeping on MySQL. And then data processing, that's just Python over some data processing code. Visualization, again, Python and SDDAS. And then we have volumes for managing our certificates. So for HTTPS, you need to keep certificates. And that's actually quite a bit of a challenge. I was kind of expecting it to not be as annoying as it was. But when you're doing everything on a VPN, then it also can't call out to a certificate authority. And so you have to convince each container that you're actually who you say you are. And then we have a worker space volume, which is just where these kind of a shared space for different containers in a pod to like communicate with each other or to store the things that they're working on. As I mentioned, containerization and Kubernetes especially gets very complicated very fast. And so this is a website which just shows you the landscape of all the different options for Kubernetes and containerization. And so it's like, if you want to pick a database, here's like 40 different options. And obviously that's not feasible to go through. So at some point you kind of just got to go with what you've seen things work for and not worry about all the noise because there's a lot. And there's always the newer, better one that's 0.5% faster, but you want to make it manageable as well. So then how did we take all of our applications and put them in a way that that can use the things I just talked about, where we can actually take the jobs and put them somewhere else to go be chugged along with. So again, following a lot of the Galley stuff to get started, we created an env, and a pro tip is to just link the config.env to the main root of it, the project, so that when you do vim env, you actually end up where you want. But we keep the configs that will change based on the deployment. So if it's like a test versus a production one, all these database variables are going to be changed. And it can be read in both by the Docker Compose and by CakePHP. Then we use the default code in Bootstrap for reading in that env, but we've modified it a little bit to check and see if it's already loaded in the env, because we hit something where when we're running CLI commands, it got mad that like it's already defined, and we're not quite sure why, but this fixed it. So again, moving on. So then we wanted to take the parts that could be containerized and move them into modular areas for being able to do so. And so we approach this in two different parts. We separated into plugins. And so we have a plugin for all these different spacecraft missions. So this is, you're looking at the plugin folder for the generic science operations center that I had mentioned earlier. And we basically have each mission in there. And when we deploy, we can delete all the other ones and everything works. And we also have a few things that are common between a bunch of them. And we have those as their own plugin as well. So you can see health and safety. Those are for plotting the health and safety data from the spacecraft. And then queuable tasks are where we put all of our queue stuff, because not all of these sites actually need queuing. Some spacecraft just don't need that kind of data. And then we have on our own Bootstrap where we go into the plugin and read that config. And so you can see here's an example of CODIS. And in this case, there's very little stuff in the plugin. It's literally just the things that are being overridden from the main. But we also don't want stuff cluttering the main that only gets used in that specific spacecraft. And then we also have like the CSS and stuff where we use CSS variables. And so the base just defines everything with CSS variables, and then we write the variables in the webroot folder in the plugin. Here's an example of what like essentially the app local, but the app for that spacecraft instrument is. And so in this case, we have the health and safety plugin, which is an additional plugin that we've defined. And I'll show in a second how that gets actually loaded into the application. But these parameters can change frequently, especially as the instrument is being developed. And so we didn't want these stored in a database because that becomes just more involved of a process, whereas this one we can literally change, as things go on. And it's one place to change for the spacecraft or for the instrument. And then we have some constants like the site name and stuff like that. So how that actually gets in, which this part I'm not convinced is the best way to do it, but it's kind of an override that we've done. And so we read in that additional plugins array, and then if it is in the array, or if it's a valid thing, then we do add it to PSR4 so that PHP knows where those classes are, and then we do the Cake add plugin for that plugin, and so Cake knows that it's a plugin. And we've overridden our routes to go to the plugin folders controllers first, and then we have a middleware that if it's not there, to bump it back to the base. And so it's kind of a convoluted way, but it actually works really well for what we wanted it to do, and where we don't have just files that don't do much of anything because it's more segmented, I guess. Then we've also done modularization on the for queuing. And so we first started with DeNeuroMarQ because it's much more like straightforward than going to the CakePHP queue, because there's, you just have the thing and it's local and you get things like progress bars and abort and requeuing. And so we now actually include both into our project, and the Cake queue one only gets called if that queuable tasks plugin is in the optional plugins config. All right, and so that allows us to have our program call out to these containers over Rabbit using CakeQ, but then not rely on having to only do that. And so we can run things locally. And then another thing is we really like the templates and views that come with DeNeuroMarQ. But another problem we had is that the configs actually conflict. And so that actually was kind of a challenge because, we have the queue for CakeQ in the main, or for DeNeuroMarQ in the main, and then in the queuable tasks plugin, we override that by deleting the original one and writing the one for here. Because they use the same key, and so they get really mad, actually, if they're both there together. And there were a couple different things I tried, but ultimately this was the way it had to go. And then it actually causes some issues on the CLI side as well, because sometimes I try to run a queue and I end up at the wrong one. And so haven't completely figured out the best way to manage that yet. But the way we handle the jobs, because they also operate differently on using a job versus a task, is we have a common code called process mediator, and this is actually where the where it actually calls the job to do, but we have a job and then a task for different ones, so that way it can be handled by whichever one is available. And so we have that fallbacking in there. That's about it on the, I guess, the changes we made to our code to be able to make these deployments happen, and have it be that hybrid that I mentioned, where you can still have your code running, your Cake app running on bare metal, but then have all this complicated processing stuff somewhere else, which is also important because sometimes we end up with errors like where it actually crashes the PHP thread or something, and that would actually be really bad if it's on the same system as everything else. Or it locks out, the plotting software takes up too much memory and it kind of locks out everything else. So now in this case, the container uses too much memory, it doesn't matter. Just kill it, or it'll die on its own. It's not affecting anyone else. It can go, eat glue in the corner. And then we've done pretty much all of this over just the past year. So we're still very new into this space. But we've found a lot of tools that have been helpful and some that we've had trouble with kind of wrapping our heads around. I'm just going to mention these real quick on what we found that's useful for making these deployments that are agile in both being able to adapt to customer requirements and also agile in where they're deployed. But Rancher is one, and that allows us to manage Kubernetes, because managing Kubernetes from the command line is very difficult, and you don't really know what you're doing sometimes, whereas a GUI is kind of nice. Um, Another one is Dashy. And so this one I'm going to show, but essentially when you spin up all these containers using their own Docker composes, then a lot of times you'll define the port in the Docker compose, but you can actually just leave that blank and it'll pick a random port. And a lot of times that's easier when you're treating your containers like cattle, where they're essentially disposable. But you'd still want a way to keep track of the ones that you use all the time, that you keep live and up. And so in that case, we have this Dashy dashboard for going to the two different clusters we have and the two ranchers we have. One is on our on-prem server, which is our development server. And then another one is actually a high-performance computing cluster that we have access to. And so that's actually the goal for this, is to have these containers on that high-performance computing cluster. And then all of this processing just happens like super fast, because that server or that high-performance computing cluster is literally just sitting there depreciating in value because we're not using it. And so we might as well use it. It's not just for us. It's for a lot of other sciences. But again, we have access to it. Then for managing our containers and our code, we have these in a Git thing hosted on our in a Docker container. And people have mentioned GitLab before, but it's essentially a more free open source software version of GitLab. I wasn't entirely sure on GitLab's licensing, and so it just seemed easier to go with Git. And it provides us the code in a Git server, and it also provides us with a container registry where we keep all of our containers that we've now built with these different space science software and can include in these different environments, while having this all in VPN and not open to the public. And so we found that one to be very useful. Then dependency track. This one is good because now you have a lot of dependencies, and so it lets you be able to manage those, but honestly, the keeping track of that many and like updating it and that proved to be a little more work than it was worth. Then we have Watchtower, which keeps these containers up to date, so you can specify which containers that you always want it to just go through and check the latest on. Longhorn and MinIO are storage solutions that we haven't quite gotten to using effectively yet, but MinIO is like an S3 storage bucket that I mentioned earlier, and it allows you to have all your containers use that, because there's no such thing as a local file system when you're like on the cloud. Prometheus and Grafana are for like logging and metrics. We haven't gotten to using those yet. Traffic is for like port management. Colima is helpful when you're doing Docker on a Mac. And then Cockpit actually comes with Rocky Linux, but it's helpful for seeing what containers are using what amount of resources and seeing which ones have died and going to the logs and such. So I can go and see the logs from a certain container. Well, this one doesn't have any logs, but this one does. And so you can see all this from that dashboard. And then lazy Docker, lazy Kubernetes are kind of like that, but in the terminal. For what's next, we want to tie all these different parts that I've mentioned together, and also collect metrics on like how much faster things are. We know it's going to be faster being on the high performance computing cluster, but we want to be able to show how fast. And then CI/CD. So Git has actions in beta, and so by the time we're ready for it, I think it'll be there, but we're not quite ready for it. And then auto scaling, we want to be able to have the container that's running on the server read the RabbitMQ queue and then spin up the number of containers to best manage that queue, rather than just having one or having a ton just sitting there for no reason. And then we want to optimize these containers because they all have Ubuntu, but by using Alpine, we'll be able to like slim down those containers, and then be able to fall back to AWS is something we haven't accomplished yet. And then better managing certificates, because when you're on a VPN, then you have like HTTPS certificate things. And then this is a YouTube channel that I recommend. He has a giant home lab, and he actually runs pretty much every tool that I'd mentioned just at his house. And he has like, I don't know, 6 different servers running. And there's a lot of good info that he's provided online. That is about it. I wanted to thank the people at Swiri that work with me on this. So that's Joey, Steven, and then Keith and Carrie. And then, as again, these slides are available at the URL. And that'll open the floor for questions.
Any questions here?
And feel free to reach out on Slack or email or however you want. I'm very open to questions, and I'm happy to respond to, yeah. All right, well, I guess I have 3 minutes, so if there's no questions, then I can actually show you what this looks like in when it's actually running on the site. So in this case, actually, I don't think, no, yeah, I can do it. So we got to turn on these containers. And if anyone does have questions, feel free to stop me in between. So we have the part that's in the container on a completely different system, and then we have the part here that listens to the response that comes back from the Python code. And so in this case, we have Python that's running. And actually, I'm going to kill that first. And we can go here to standard plots. And so this has stuff drawn in it. And so we hit generate plot. And so now if we check the queue, we now have a queue for the plot, and we now have a queue for the return. And then if we run the thing to process the queue, we see the info has populated here. And it responded with success, and it sent it back. And so now on the web server, it's gone ahead and written that file to where the web app expects it to be. And so now we can see it. And now all that complicated stuff is not happening on the web server. It's happening somewhere else. And we can continue to play with it as if it were basically local. This plot's not very interesting. That's it for me. Are there any more questions on Slack or anything? I haven't seen it. Cool.
All right, thank you.